So we'll move on to our next talk by Timothy Livengood on the topic, the case for a geologically neutral site at temperate latitude. Timothy, are you there?
Somehow I thought there was another person before me.
Oh, not a problem.
All right, hi. All right, so I am going to argue for why we should go to some place that is actually pretty much as dull as possible with my colleagues here, mostly from Goddard Space Flight Center and University of Maryland. So next slide, please. And the goal will be to look at the global phenomena that happen every place on the moon, including space weathering, hydration, and the diurnal variation in hydration on the surface, or at least what appears to be diurnal hydration, and the surface gardening. And there's some context for that in the scientific context for exploration of the moon, with two of the concepts that are addressed in there are things that could be directly addressed by this. And in particular, I want to point out a surface phenomenon happening in this particular picture, the halo around Neil Armstrong's head in the shadow here due to the very low phase angle measurement there, essentially opposition effect. And one of the things we want to understand is the actual physical structure of the surface that leads to opposition effect events like that. So next slide, please. So a problem with going to unique locations is that they're unique. They have a unique history on which is overlaid the global phenomena that happen everywhere on the moon. But in order to distinguish the two, you'll need a substantial supply of unique locations that you have visited before you can really fully dissect the separation between what happened uniquely locally and what is global on the moon. Whereas if you go to a place where essentially nothing's going on other than the global phenomena, you can make that straightforward. They also have, of course, unique geochemistry in unique locations when we look at the at volcanic provinces. And these properties lead to unique instrumentation also. It's designed to exploit that particular location and often may not be ideal for measuring the things that happen globally, or they may not even be capable of it. And of course, I think of the way we got through decades and decades, okay, multiple decades of studying the moon without noticing that there's a hydration cycle because we carefully avoided looking at water because we knew it wasn't there. And then finally, there are incentives against having global capabilities in a focused mission because you are always having to deal with the question of how do you deal with finite resources, very restricted resources, that if you're looking at a phenomenon that could be measured anywhere in the moon, then why would I be spending my unique resources measuring it here, or my limited resources measuring it here? So I want to go to a place where we can do exactly that, measure these interesting global phenomena. Next slide, please. And so we can select a site that's dominated by the global properties that are happening, the things that are happening everywhere on the moon. It provides us a control site that we can use to understand those global phenomena and then use that for comparison to all of these other interesting locations that we're hearing about today. It represents the majority of the lunar surface. If you look at a map, which we will in the next slide, don't go to it yet, we can see that the majority of the lunar surface can be represented as kind of essentially bland. And then, of course, it has unique locations buried within it. One of the things, though, that we would also want to look at is the representative undisturbed surface of the moon. So at any location, you can look for having the value of mobility to get outside the blast radius of your rocket motor. But we want to understand what are the things when you do that that are representative of the entire moon. Since we also have
1 minute left,
relatively
Timothy.
1 minute, okay. Since we have relatively coarse information on mineralogy everywhere on the moon, high resolution sensing at even a nominally bland site is important to understand, again, what kind of distributions we have locally. And then finally, we want to look at microscale phenomena that are invoked throughout the solar system, all over the moon, but on asteroids and other bodies too, to understand the photometry of those sites and hydration. I'll just say the word. Next slide, please. And to do that, you need a representative site. You need to be able to map mineralogy. You need a microscope, and that means you need mobility to get outside the region that you've just damaged with a rocket motor, preferably on the near side, because that makes downlink simple, and preferably with a capability to examine the subsurface too. But that is, again, not quite as critical. And I'm out of time. Next slide for my pretty picture at the end. There we go. I don't even need 1 decimal point.
Thank you very much, Timothy. That was a very interesting presentation.